Okay. Good morning and good afternoon. Uh, Thank you for attending another one of TAC-YM's Introduction to Tunneling webinars. Today, we are excited to be joined by Connor Langford, who is going to be talking about the introduction to risk management. And so Connor Langford is the Canadian Tunnels team lead at Mott MacDonald and has nearly 15 years of experience in the design and construction of underground structures in Canada, the US, and overseas. He has worked on a range of tunnel projects across a number of different industries, including transportation, water supply, and energy. He holds a doctorate in risk management for underground construction and is the risk manager for a number of local and international projects. Connor is passionate about engineering education, giving guest lectures at both UBC and Queen's University, as well as volunteering at Science World in Vancouver. When he's not working, he loves to spend as much time outdoors as possible with his family, including his not-so-small puppy, Watson. Connor, I'll let you take it away.
Perfect. Thank you very much, Tim. Good morning and afternoon, everybody, depending on where you are. Really excited to be talking to you today about a topic that's very close to my heart, which is risk management. So just before we get started, I just wanted to kick off the meeting with an EDI moment, which was graciously supplied by a fantastic group, which is the EDI task force within the Tunneling Association of Canada. And the moment I wanted to share today was on unconscious bias, which is it's defined as attitudes or beliefs about certain groups that people will form outside of their own conscious awareness. And this is something that is particularly relevant to me right around the time where we go out and we put requisitions out for hiring, just because it is it's a really important thing to think about when you're reviewing resumes and doing your interviews as well. And so how does it impact your workplace? So if you were to allow these unconscious biases to influence your actions, you might actually be missing an opportunity to create a more diverse workplace. And that's something that's really critical for us as an industry in particular, but also I'd say for every workplace. Now, some examples of unconscious biases, they could be related to age, weight, gender, beauty, name, height, religion, culture. The thing that always that sticks out to me too is unconscious bias doesn't have to be negative. It doesn't have to be you are unconsciously avoiding a group of people. You could also be unconsciously providing a sort of undeserved benefit or perhaps too much focus on a group of people as well. So really important to consider that. Now, ways to avoid unconscious bias, there are some really great tests and training that you can do. The one thing that I like to do is sort of reflect backwards and just go and look at, particularly related to hiring. So who did I look at resumes for? Who did I give interviews to? And then who have we hired in the past? And just making sure I'm trying to identify if there are any trends here that I was not aware of that start to emerge when you look backwards through that data. Okay, let's dive right in. So today we're going to talk a little bit about the introduction to risk management, specifically focused on kind of underground projects, tunneling, mining, etc. Now we've got, just a little under an hour here. There's a lot to cover. Probably every one of these sort of 4 items here that I've got could be a talk in and of itself. So my goal is to give you the first sort of background in risk management so that if you're at a cocktail party and that topic comes up, you feel confident about talking about it. But obviously there are lots of follow-on talks if you really are interested in risk management and would like to do that more in your career, which is something that I actually discovered more through accident than purpose. Just started doing risk on jobs and ended up becoming really passionate about it. So let's start by talking about the risk in underground projects here. So underground projects carry really unique risks. When we think about a tunnel as an example, there really is no workaround. If you were to encounter an obstruction when tunneling, we're often on the critical path of the job, which means if we stop, the whole job has to stop, and then the whole schedule just gets pushed to the right and delayed. So really, really limited opportunities to have workarounds when you're doing the construction. So therefore, risk management earlier on in the process is really critical to the success of the job. We need to understand what kinds of impacts these risks have on project. It could be a cost to the job. It could be a constructability delay or a construction delay. There could be constructability issues where a contractor is engaged and they actually can't do the thing that you were hoping that they could do. So lots of really negative outcomes could occur as a result of not having a good risk management process. the core concept for risk management really is trying to take those risks that we identify and get them to an acceptable level. And acceptable is a really important word here. There's lots of times where you might be sitting talking with somebody about risk management and they say, you know, we're not going to rest until we get that risk down to zero. And you know what? That is absolutely impossible. There are extremes to risk management. There is doing everything you possibly can, which is wildly expensive. There is the other extreme, which is doing absolutely nothing, which, so I would say in this day and age is irresponsible. And then there is a huge gray area in the middle that we try to understand as best as we can and try to pick out where do we want to sit for this particular project. Now, why does risk management matter? That's probably the first thing we should all be asking ourselves. Okay, so it's a process we can use, but why? So unsurprisingly, on our sort of underground project jobs, when there is a problem, so whether it's a collapse, a fire, a flood, these can have significant impacts on the job. So these can have significant schedule impacts, and we've all read articles around mega projects being delayed. The Boston Big Dig is a great example, and that has a really negative outcome because then people think, well, why are we building these projects in the first place? We shouldn't do that in the future. So there is sort of a reputational impact that can occur. There is a cost impact, which we can see here. So these are just the major issues on construction projects between sort of 1995 and 2015. More than $625 million US occurred as a result of these losses. And then there's big schedule delays where, you know, people are relying on these transit expansions to get to and from work, and they're 1, 2, 3, 4 years delayed as a result of risk, which creates issues and hardships among the people that we're trying to serve. So we'll start by sort of looking at this at the very basic level, and then we'll build out from there. So when we talk about the idea of risk, that word can often be misused. So when we say we have a risk, it's really defined for a specific hazard. So what might happen? So let's look at an example here of a rock fall on a roadway. So what is the hazard that rock will make its way down to the road? And that consists of two parts. There is a probability. So what's the likelihood that rock will separate off the slope? It'll roll its way down the hill. It will land on the road and it will stay there. And then what's the consequence of that occurring, which in this case is a car striking the rock. So that could be damage to the vehicle. That could be a health and safety hazard in terms of an injury to the occupants in the car. So it's really, really important when we talk about risk to consider the probability of something happening and the consequence of that happening as two separate entities. And the reason we do that is because we might want to try to address the risk or to actually manage the risk in a different way, depending on if we want to reduce the probability or reduce the consequence. So let's look at a couple of examples of how we might quantify risk for certain hazards. So this is an example from Northern Ontario in a mine. This is a scoop tram. You can see pictures of what an intact scoop tram looks like on the right, and then a scoop tram that has actually been crushed by wedges that fell out of the roof on the left. And so really the hazard here was the idea of rock fall within a drift. So would this be a wedge failure within the roof of your drift? And the probability of that happening, as evidenced by the fact that it did happen, was quite high in this case. So there was a concern about unfavorable joint sets, which could result in some pretty large wedges falling out and the support not being able to support those wedges if they did. Now, the consequence of this could have been drastic. So could have been so if this was operated, it would be a loss of life, which is absolutely unacceptable. So identifying that as a possibility that had a high likelihood of occurring, this was a remote operated scoop tram. So the consequence of this happening is the loss of equipment, but not loss of life. So then at that point, you can compare the risk of losing this equipment to the opportunity of being able to advance that drift to get more ore out of the mine, and you can make a cost comparison that way. Another example, not sure if you're still learning about this in school, but the Yakambou Keyboard Tunnel was a huge case study when I was back in school. Really, really interesting project. It was so a 23-kilometer long tunnel. Started construction in 1976, completed construction in 2008. So quick math, that's 32 years, which means they advanced the tunnel on average, a total of 700 meters per year, not a record advance rate for sure. And one of the issues on this job, the geology was a squeezing kind of phyllite. It was a very weak material that was able to squeeze into itself. And the investigation work that was done was at either end of the tunnel where they had good quality rock. So they sort of assumed that rock would continue for this whole tunnel. So they picked a machine, a main beam TBM, that would be able to excavate this quickly. And what ended up happening is the workers went home for a long weekend on a Friday, and they came back on a Tuesday and found that the ground had actually squeezed in and crushed the tunnel boring machine in place, which you can see on the lower left-hand picture there. So while this was still our sort of loss of equipment, like we saw last time, these are very expensive machines, caused a considerable delay to the project and a major reputational sort of hit for this project as well, just given how long it took to be completed. Now, if we switch past the sort of loss of equipment and we move into other hazards, so it's important to remember that in our industry, we do have some very significant hazards on projects, and if they are not managed properly, can have significant consequences. And this is an example of one. This was an undersea tunnel in Japan. It was just about 5-meter diameter TBM. And in February 2012, they were excavating and it hit a sort of depression within the bedrock, which allowed it to communicate with the water above, and the entire tunnel was flooded during excavation, which so killed 5 workers. One person was closer to the shaft and was actually was pushed up and out of the shaft at the time and survived the incident. But so this is an example of a very extreme risk. Now, the probability of that happening may not have been understood, but the consequence associated with loss of life is considerable and is completely unacceptable for us as industry practitioners to accept. So this is something that we always need to keep in the back of our head. And so we talk about risk in kind of an abstract way, but it does have real impact on the people that are constructing the job as well as the end users as well. Now, the other thing to keep in mind for risk is there are lots of different risks that we need to consider, and there are a bunch of different factors. We tend to zoom in a lot on our design risks and our construction and procurement risks, but really there are a considerable number of risk factors that we also need to consider for any job. And those include our sort of stakeholder, our environment risks. So we have market risks related to competition and escalation. So on the owner side, they're often worried about political and legal risks, so as well as operations risks. And not all of these might occur on a job, but at the outset of a project, we always want to consider what kind of risk factors we need to manage. And for us as engineers, we might think, well, how are we going to tackle this really difficult design question? But the owner might be saying, you know, my biggest risk is being called by the mayor to ask why the project is so delayed or why the project is over budget. And understanding what our clients are dealing with and what the owners of these projects are dealing with, as well as the contractors and the designers, is a really important part of risk management. It's just understanding each piece of this and then identifying who is the most able to manage that risk. Now, how do we deal with risk? Really good question. Lots of things we can talk about here. So just wanted to hit the 3 main parts of the way we deal with risk on projects. And that is, first, the analysis side. So really just trying to understand that probability and consequence of a given hazard. So we go through our full project, we identify all the hazards we have, and we try to understand, you know, what is that probability or consequence. And sometimes we can do that with numbers, which is it's a more quantitative approach. And sometimes we do that on a more qualitative side by using words like, you know, low or medium or high. The next thing we need to do is assess that risk. So once we know what the probability and consequence is, we might get a score at the end of that. But that number is meaningless if we don't understand what would be acceptable or what would be unacceptable. And that's a really gray area because it really varies from industry to client and even to geographic reasons. So that'll change quite a bit from project to project. And then after we've identified what's acceptable and what's unacceptable, we need to try to manage the unacceptable risks and get them down to an acceptable level, or what we might call the as low as reasonably practicable level, which we'll talk about in a minute. And we do that through our control and management measures. So starting with our sort of risk analysis side, so as I mentioned, there's a qualitative approach, which you can see on the left, which is nice and easy, you know, medium, low, high. And then there's a more quantitative approach to understanding the risk, where you're actually assigning a probability number and a consequence number, so whether that consequence is a cost impact or a schedule impact, and trying to understand what is the distribution of potential costs or schedule delays that could come out of that risk. Once we've done that, we'll move on to risk assessment. And that's really a conversation. This isn't something you can just do in isolation. So trying to understand the assessment of each of your risks is a conversation with the owner. It's an understanding of what you're building and where you're building it. And in the past, there has been a philosophy around, well, there's only unacceptable and acceptable risks. And the difficult concept there is that it might be hard to bring an unacceptable risk down to a purely acceptable level. So they've created a zone in just in between unacceptable and acceptable, called as low as reasonably practicable, or ALARP, which is a terrible acronym and does not roll off the tongue at all, but gets the point across that if you move a risk from the unacceptable zone to the as low as reasonably practicable zone, you can decide within that zone if you want to spend more money and time to continue to manage it down, or if you feel that there's sort of diminishing returns by continuing to spend time to try to mitigate that risk. And so as an example, on the right-hand side, you can see a plot that shows the line of acceptable. So everything above that, or so below that, sorry, is acceptable. You then see the marginally acceptable line. So anything in that zone in the middle is kind of as low as reasonably practicable, and then above that would be unacceptable. Now, what's interesting, so I mentioned that it's really dependent upon the owner, the geography, so as well as the time. So this was developed in the late 1970s, and then there was an update to this in 2000, where new lines were drawn as to what was acceptable, what was unacceptable, and what was as low as reasonably practicable. And you can sort of see that those lines have shifted. So depending upon the risk tolerance of the owners and the users of these, you might actually notice that what used to be an acceptable risk is now actually unacceptable and needs to be managed. Now, once you get through the assessment phase, we have a good understanding of what risks there are on the job and which of those are either unacceptable or currently plotting in the as low as a reasonably practicable zone. And that's really where we get into the good stuff for risk management, where we need to understand how do we take those risks that are unacceptable and how do we try to mitigate them down to a point where they would either be acceptable or as low as reasonably practicable. And the reason I say this is the fun part is because really everybody has a role to play as part of this process. So our clients, the designers, contractors, equipment manufacturers, everybody gets involved in this part of the process to put their heads together and understand who is the best the best or most able to try to manage that risk, and what can we do to manage it. And this is not done once, it's done continuously through the entirety of the project. Now, the way you try to manage risks, there are a couple different ways to mitigate them. One, you can just accept the risk, which is actually, that happens all the time on jobs. If we can get the risk down as low as we can, at that point, we just have to accept that there is a residual risk that we need to be aware of during construction that could impact either the cost or schedule for the job. We can try to avoid it, which is something that we have a lot of power to do at the earlier stages of the project, and then very, very little as the project goes on. So really important to identify those early on. You can transfer the risks, and a lot of that happens at the time where we move from design to construction through procurement documents. So you can identify, we have been tracking these risks. We now believe the contractor is responsible to manage them, and you can sort of transfer them to the contractor to take over from that point. Or you can try to reduce or manage that risk down to a certain level. So by using control or mitigation measures, you can either reduce the probability or the consequence of the risk you're looking at to a more acceptable level. A really powerful tool to do all of these things is the risk register, and that's a document. There's lots of different ways to draw these up, but they really tend to contain the same 4 pieces of information. One is identifying what the hazard is. So the next is doing an initial analysis and assessment on what the risk would be. If we didn't mitigate it further, we can establish a risk mitigation approach to try to reduce the number. And then really importantly, the responsibility. So who is going to carry this forward? What is the action here? So where will the risk be managed? What's the actual document that it will be tracked in? Who's going to do it, and what date are they responsible to complete it by? The one thing I would say, after doing a fair number of these, there are jobs that view the risk register as just a deliverable, and that's really a mistake. So the idea of preparing this and then handing it over and then really never looking at it again is not the most useful way to look at risk management as a process. This is a really powerful document and tool that you can use in design and procurement and in construction to understand and try to manage the risks effectively. So would really encourage you to, if you're ever involved in a risk workshop or the development of a risk register, really think about it as a living document that needs to be watched and updated as the project progresses. Okay, so I've talked a lot about what risk is. How do we actually try to address the risk and manage risks during the design phase of a project? So as I mentioned before, I mean, design is really one of the best times to understand your risks. It's a time where you have the most control over how you manage them. So whether you want to come up with a sort of value engineering approach to avoid a risk or to try to manage it in an effective way, you've got a lot of power at this phase to manage those risks. You also have a lot of power to identify opportunities, and talks on risks tend to just focus on the negative, things that can go wrong, but really as good risk practitioners, we also want to look at opportunities to either to save costs, to save schedule, or to improve the overall safety of a job. So whether that's during construction or during the operations phase. And so as the project evolves, your understanding of risk will change. And so that's why we need to continue to revisit this. Now, during design, there's really two items that are worth sort of delving into a little bit more as to how we try to manage the risk. So one is the risk of uncertainty and variability. We tend to work in a really interesting field where we have materials that have been worked and reworked over millions, if not billions of years, which is really difficult because there's a lot of spatial variability that we need to account for. And there's a really good example up top there of a geologic cross-section through the Alps, lots of variability within those units. But we also have a hard time because we don't have a lot of site investigation data. If you go to 2 or 3 different labs to test, you might get slightly different results. We preferentially choose good samples to test, which means we're not testing the bad. So there's lots of uncertainty that exists that we need to manage as well. And then the second item that we try to do during design is a good understanding of cost and schedule contingency. So we have a cost estimate and a construction schedule is usually prepared, but how might that change? Could it be higher? Could it be lower? Could the schedule be longer? Could it be shorter? And that's something that we really need to look at to assist the owners in understanding what is the range of values that I might experience on a job. So if we talk about the first item, this is a quote from Donald Rumsfeld, and it probably doesn't really resonate with the TAC-YMs because this guy is pretty old, but I mean, it's a really, really interesting quote as it relates to uncertainty within our field. And he talked about the idea that there are these known knowns, so things that we know that we know. There are known unknowns, which are things that we know we don't know. And there are unknown unknowns, which are things that we do not know we don't know. And when we think about this through the context of underground construction projects, so our known knowns, I mean, we will generally have a good idea of our preliminary tunnel alignment and depth. We might understand what kind of geology we're expecting at a basic level. And so maybe there were other construction projects in the area that have taught us a little bit about how the ground has behaved. So those are things that we can kind of tangibly understand from the beginning. As we get started, there are then a bunch of known unknowns. So things that we are aware of will have variability or uncertainty associated with them. And those are generally related to our parameters, things we can try to test through site investigation and laboratory testing programs that we are doing our best to understand the variability and uncertainty associated with them. So the last category are those unknown unknowns, which are really, they're the things that we might not be aware of. So if you drill 2 holes and you find consistent geology, that doesn't mean there's not a dike in between. And so those are things we do our best to think about and to understand what could be there. But at the end of the day, we don't really know everything about the ground we're going to be excavating. And therefore, there could be some anomalies or discrete hazards that are encountered. There are lots of different tools to try to deal with this uncertainty and variability, and this could be a presentation in and of itself. But really, I mean, the previous way was to think, well, let's just pick the most conservative values and we'll just design for something that is so robust it couldn't fail. And that was successful for a long time in terms of presenting failures, but it did lead to over-conservatism, which causes project costs to increase. And at the same time, choosing the lowest value is not always clear. And so in situ stress is a good example of this. Is a higher value or a lower value worse or better? That will vary depending on the job. So choosing the higher stress doesn't always mean that you're going to design for the conservative approach. It could mean you're actually kind of missing a way in which the rock could fail because you've chosen a conservative value. So a more formal approach to addressing that uncertainty hasn't really been established, but there are lots of tools that can be used. And there's a couple that are shown here. There's the observational method where you design for a bunch of scenarios and then you sort of install depending on what you encounter. And that's used a little more in, I'd say, Europe than we see in North America, but it's a very powerful tool to address uncertainty and variability. You can use partial factors, which our sort of friends in structural engineering are very well versed in terms of load and resistance factor design. There's domaining and classification systems, so breaking your alignment into a set of discrete pieces, and then reliability methods where you discretely use that uncertainty or variability in your parameters to design for a bunch of different cases. And so if we look at an example case study of how you might deal with uncertainty and variability in your parameters, this was a pillar design I did back in the very sort of early stages of my career. We were looking at trying to develop a series of rooms that were separated by a pillar and deciding how big that pillar had to be. And obviously, the larger the pillar is, then you have a much greater footprint. So there is an optimization piece here where you're trying to keep the pillar as small as you need it so that you don't have to excavate more material when you're establishing these rooms. And so if you were to run just one case, this is a numerical model we ran early on just to look at the potential sort of damage to the pillar for a certain spacing and excavation, you might come up with an assessment that says, hey, only about a third of the pillar is going to be damaged on either side, which leaves us with a core of about 2/3 of the pillar left. And you know what? That's enough. That's going to be great. And that's what we can expect to see during construction. When you start to look at the uncertainty and variability in your parameters, you might notice that actually there's a range of potential behaviors that could occur in this pillar. And some of these will be acceptable, some will be marginal, and actually there will be a number of possible parameter combinations that would be unacceptable. And so once we start to understand that, you can start to look at the distribution of those and how many cases do we think would have a certain depth of failure. And once we understand that, we can choose a bolt length that's going to extend through the failed zone and into solid rock. We can also look at the range of potential loads on bolts. And from that, we can choose which type of bolt we think should be used that addresses that potential range of loads. So lots of really powerful tools you can use to understand that design uncertainty and variability. Now, the second item that we like to look at during construction is, the design phase, is construction contingency. And one of the most sort of powerful outcomes from a design process is not only the design package itself, but also some form of estimate of the construction cost as well as the construction schedule. And really, the main benefit of that, so that goes to the owners to understand, well, how much money do we need to ask for a project? And then also we need to communicate the construction schedule to our key stakeholders, to the community. And so we use that and we think about, okay, well, what could this cost and how long could this run? But there are lots of reasons why a cost estimate and a schedule would be used outside of just the engineering side. And that's something that we really need to consider. So understanding, so this is our cost, but how high could it go? Or this is our schedule, but how long could it run? Is really, really important information for owners to be able to communicate potential project outcomes so they will typically be evaluated against. So once an owner says it's going to cost this much and it's going to run this long, if it's higher than that or longer than that, there is a reputational hit to them as to, well, it was over budget or it was over schedule. So really, really important for us to understand that side of risk as well. And the way we do that is we would develop a risk profile, and that's typically done through what's called a sort of quantitative risk assessment, or a QRA, which is probably something you've heard of before. And I think the really important portion of this is that if we're taking a cost estimate or a schedule and then we're adding risks to it, we need to make sure we're not double counting. And this is why it's really important for the cost estimators and schedules and the risk people to be communicating at all times. Because if a cost estimator were to include a bunch of conservatism in their estimate, and then we also include that conservatism when we do the risks, you're sort of double counting between the two, and you're making it look worse than it actually would be expected to be. Now, so the outcome of that, really, really powerful tool, but it also adds a degree of complexity because now essentially there's an infinite number of outcomes. There's not just one answer to how long will this project take. And so that introduces a concept called confidence, where we need to say how confident we want to be that a cost will not be exceeded, or a scheduled completion date will not be exceeded. And as you increase your confidence, unsurprisingly, the cost of that would increase. So if we want to be more and more sure of what it could be, you're going to see your sort of project costs increase and your schedule as well increase. And if you go too big, that might mean the project doesn't go ahead. So there's a fine balance here in understanding what is your risk profile, what is the confidence you want to have, and then communicating that to the public. So if we look at an example of a tunnel project that we're working on up here in Canada, you might have a cost estimate that produces a deterministic value, and that value of $43 million, that includes the base cost of construction as well as some estimate of escalation that could occur for the time when the project goes ahead. Now, once we take all the risks we had in the risk register and we do a QRA, you're going to actually see that straight black line that is one value turns into a range of possible outcomes. So now we have a project cost that could range anywhere between $236 million to $350 million. And that reflects the uncertainty in our cost estimate. That reflects our sort of risk costs, where there could be more material costs that would factor in. And then also our sort of risks that impact the project schedule, which means there's more cost for the job running longer. And so at this point, we would then need to look at, well, how confident do we want to be in quoting a value? So if we said we'd like to be 80% sure that the cost will not be higher than a certain number, we would say it's about $281 million. And so we can then say the difference between 281 and 244, that's how much contingency that we would recommend carrying. So that would be the actual project cost that would be quoted. Despite the fact that the construction cost is really just that 244 that we costed in the first place. Now, if we want to increase the confidence to say 90%, so as you see, we move a little further along that blue line, and now we need more contingency to be carried, which means the actual number that we would quote as the project cost would be higher. So it's a really fine balance of understanding what is an acceptable confidence level, which will then inform what your cost or your schedule would be. So once we establish that, we need to understand how we pick a number. And so that confidence is not something that we as designers or engineers would decide. It's a conversation with the owner. So understanding, so what is the risk tolerance? What is the stage of the project? We might see a higher confidence being desired closer to construction, because that's a point where the project is more understood. And so reevaluating what that confidence needs to be is really important as the project proceeds. Now, once we pick a confidence number and the owner says, you know what, I'd like to be 90% sure that I'm not going to exceed my construction cost, we then have a contingency value that we'll be carrying. And so if we go back to the last plot, if we wanted to be 90% sure, that's saying to us we need about $50 million in contingency. Now, that's just a big pot of money. So what we'd like to understand as well is, well, when do we expect to need to spend that contingency? So maybe the project is 5 years long, and there are a couple of discrete milestones that we really care about. And those might be the completion of a shaft, the completion of tunneling, and then the completion of our sort of concrete works at the end of the job. And you can sort of see on the plot to the right here, the way we might try to map out the way that contingency is spent. And so in this case, we're saying we've got about $14 million of contingency. We think that by the time we're about sort of 60% through the project, we're going to have spent about half. And then we can track how we're spending that contingency against time. So we can see if we're spending more money on risks than we thought, or if we're on track, or if we're spending less money. So a really, really powerful tool to sort of understand as you move from design into procurement and construction. So then the next phase is we're moving into procurement. So understanding, what are the ways to manage our risk now that we've completed the design phase, and then as we transition into construction as well. So once we get to the end of design, there's a couple of things that should have been done by now. So we have done our sort of risk management system. We've developed that. We have a risk register that's been completed with the owner and a set of ways to manage risk that has been agreed upon. We have a risk policy developed. How are we going to try to continue to manage risks as the job continues? And we've completed any risk analyses that we might need to have done. Now, we then have to develop a contract and a set of contract documents, and that is really one of the most important vehicles for risk management in the life of a project. So during design, you've got a lot of flexibility to understand risks and opportunities, but once you get to the contract stage, that's where we explain how those risks need to be managed. And a really, really important thing that I was told in my first year of work, actually, when I was on site, was that contractors don't accept risk, they price it. So when you pull your contract together, if you think, well, we'll just transfer all the risk to the contractor, we're not going to understand any of it, we're just going to say, it's yours to manage. What does not happen is they don't say, oh yeah, okay, we'll just take that. So that's great. Thank you very much. Thank you for explaining that that's what that is. What they're going to do is say, okay, well, if you're telling me I have to manage that, I have to assume that a certain amount of these will happen. And if it's a fixed price contract, or if it's a lump sum as an example, then the cost of those risks will be in the lump sum. So whether they occur or not, you're going to be paying for them as part of the project. So you could do that, or you could find a way to put some components of risk management into your contract documents so that there is risk, or the full risks are shared between the owner as well as the contractor. So yes, you pay for them if they occurred, but if they don't occur, we're not expecting to pay for them. And there are a number of ways to manage the risk and to communicate that to the contractor in your contract documents. You can choose what contract type you'd like to have. And so similar to confidence, that's going to vary based on the project, the owner, the risk tolerance of the owner as well. That schedule and cost estimate. So understanding what you think your sort of the base assumption would be, and then how much contingency you might need to have. That'll help inform how long you think the job will go, and you can then build in some of the requirements for sequencing if you think that that's important into your contract documents. You'd of course want to have constructability reviews. That'll help you to get in the mindset of a contractor and make sure that you are communicating design elements that would make sense to a contractor to then bid on and perform. There are sort of documents like GBRs, geotechnical baseline reports, that really help to establish a clear line between the risks that are being owned by the contractor and the risks that are being owned by the owner, so that it's easy to tell if a claim has occurred. You've got technical specifications, and there's a big difference between being prescriptive and doing performance-based specifications, and the way you would try to manage the risk is a function of which of those two you might pick. And then, of course, you can do some pre-qualification to make sure that it's a smaller number of contractors that have the experience or have the technical know-how to complete the job. So then you're sort of less likely to have a case where a person underbids the job because they don't fully understand it, and then you sort of have to go with them. There's partnering, which is really important for risk sharing, as well as just getting through the things that happen during construction and having a sort of positive understanding of how to manage risk during the construction process. And then claims. Claims are, so they're often viewed as bad, and certainly, they're not desirable. You don't want to have a lot of claims on a job. You should have a clear claims process, though, so that there is no confusion about how those would be paid out. And then at the end of the day, it's defendable. You would understand, yep, okay, you are entitled to a claim because I clearly told you that if this happens, we would pay for it. So that's a really powerful tool as well, just to understand how you're going to manage those risks if they occur. We talked about contingency management and how you would build that sort of contingency drawdown curve during design. Well, during construction, it's really important to then use that as a way to track if you're spending more contingency than you thought. And so as an example, if we go back to that plot we had before, so when we start the job and then we get to our first sort of hold point here, we think we're going to have to spend $3 million in contingency. And so maybe that hold point is related to construction of the first shaft before you start tunneling. And so as we continue the project, we get to the end of that milestone and we say, okay, so what have we spent for risks? Well, it's good news. We've underspent. We're not spending the total amount of contingency that we thought. That provides a bit of confidence that we think we have enough contingency here to manage. Now, maybe we get to the end of hold point 2, which is the mobilization of tunneling equipment and the completion of our first learning curve, just understanding as to where we are with risk there. And maybe we find it's actually we've incurred a lot more risk than we thought. We've spent more contingency because of delays, because of unexpected ground conditions. And now we have actually overspent the amount of contingency money we thought we would spend at this point. And that's a really valuable piece of information. I mean, it's not good. We are incurring more risk than we thought, but we're only 60% of the way through the project. So now we've got the full remaining piece of the project to decide, are there some new management measures we'd like to implement to try to pull in those risks? Do we need to go back to a board and ask for more money because we're currently forecasting being over budget? There's a lot of different tools you can use. And trying to understand it in real time when it's happening is much more important than getting to the end of the project and finding, oh, geez, we have a bunch of claims pending, which would put us over our contingency amount. So now what do we do? So trying to understand as construction progresses how you're experiencing risk is a really, really valuable tool. And so this is an example from a project we're working on in the States right now, where we had that sort of contingency management curve shown in gray at the end of design, and then we were tracking change orders that were occurring. And so this is an example of the design was done before COVID, and then COVID hit, and that's when construction occurred. And as you can see, we have been overspending on contingency, which was related to some vaccine mandates, to our sort of material delays, to fuel spikes, lots of reasons why these change orders occurred and why we had to spend more contingency than we expected, but provided us with the ability to reevaluate contingency management going forward and identify ways we could manage risks more effectively to try to stay on budget. So then the last item here is really the residual risk. So we talked before about how you're just going to have to accept some risk and how there's unknown unknowns that are out there. There are always going to be risks that occur during construction. They're going to be realized, they're going to happen, and they don't have to be bad. The goal here is to understand that risks will occur, and having clearly defined roles and responsibilities is really powerful, because that will keep the job moving. So even if you were to encounter unexpected ground conditions, if you've got a clear GBR and you've got a really clear claims process and a good partnering sort of process to the job, that would encourage everybody here to continue working and to understand that we have a mechanism to pay out that claim. So we'll continue the project. We'll continue to excavate. We'll continue to innovate around these new ground conditions and keep the project moving. So really, really important to not view risk as a bad thing that causes the job to stop, but rather it's an inevitability during construction that needs to be managed effectively with the goals of the project in mind. If you're on site, you have specifications, you've got a contract document for a reason. So really, if things occur, just use the specifications and apply the contract as they go through, which will keep things moving. And really important to compare what you expected to experience to what you are experiencing. So you can look downstream and say, okay, this is actually a bit different. And we know that we're going to be tunneling for 6 kilometers. So if we're experiencing this at the start, we probably need to think about how we're going to manage this going forward. So in summary, just a couple of key takeaways. So risk is a really, really important part of underground projects. We try to make sure we think about it as those two parts, probability and consequence, so that when we talk about risk, we understand which part we might want to manage. We are trying to get risk down to an acceptable level. That doesn't mean zero. We need to define that acceptable level through discussions with the owner, with the rest of the project team, with key stakeholders, et cetera. And really, so I think one of the most powerful tools you have at your disposal for risk management is the risk register. And that's something that we should be looking to and updating from the very beginning of a job, so all the way through to completion of construction. We've got a lot of power during design to manage risks as well as identify opportunities that could improve the outcome, whether that's a cost or schedule opportunity. We've got some opportunities here to consider uncertainty and variability through things like reliability methods or partial factors. There's lots of different ways to manage that during design, but that's something we should be looking at and understanding that there is a sort of variability and uncertainty associated with everything we do. And then we can use a QRA to help us understand the confidence we should have in our cost and schedule, which can then help us to produce a contingency value that would make sense given the risk profile for the job. And then once we transition into procurement and construction, that's where we really focus hard to just risk management. How are we going to apply the risk management philosophies that we've already identified? How are we going to reflect that in the procurement documents? And then how are we going to evaluate success as we continue into the construction phase? So are we overspending contingency? Are we underspending? Are we applying the contract in a reasonable way? So are we continuing to work on the job even though we've encountered risk? So with that, just wanted to say thank you very much. It's been a real pleasure to talk to you today. We've got about 15 minutes left here, and would open it to questions, and would also just let you know, feel free to contact me if you ever have some questions around risk management, whether you're interested at just sort of a basic level and sort of knowing the various pieces, or if you think that risk management might be something you'd like to go into as a part of your job going forward.
Well, thank you for that presentation, Connor. That was absolutely phenomenal. It seems like there's quite a few questions, so I think we'll. How do you quantify the level of confidence that you have, and is it based on feel, or is there an actual metric for calculating the confidence?
That's a great question. So I'd say confidence on every job I've been on has been calculated in a different way, and you'll often see like one of the biggest differences is between the public clients and the private clients. Usually public clients want a degree of cost certainty because they're going to a board to request that. So what you might see is a sort of increased level of confidence being required on the cost side, because from the outset they'd like to go to their board, they'd like to ask for money, and they never want to go back again. On private clients, they might be a little more open to saying, you know, we'll pay for change orders, we can reevaluate our sort of overall project costs as the project continues, in which case they might want to hold a smaller amount of money at the start, so that if they're reporting to shareholders, or they would want to say, we think this job would be this much, and yes, there might be some changes that would impact the final cost, but that's 5 years away, so we've got lots of time to consider how we're going to make up that money.
Amazing. Okay, so the next question that we have is, in your experience, do you find sharing risks with contractors leads to a more collaborative experience, or does it lead to a reluctance to share risk to a common risk register for fear of liability?
My goodness, these are really good questions. Actually, at the TAC conference this year, I actually gave a talk with Keith Ward from the Seattle Public Utilities Group here, and so they're currently running a really interesting job in Seattle called the Ship Canal Water Quality Project. And I'd say they took a really interesting approach to risk management that I haven't seen on previous jobs, which was to have a sit down with the contractor when they were engaged. So specifically, the contractor who was responsible for the storage tunnel construction, and to go through the process that they went through during design to say, this was the risk register, these were the key risks we were tracking. So these are the risks that we believe we have transferred contractually over to you as the contractor, and then sort of pausing, nodding, making sure everybody agreed that that was the sort of risk profile that was being shared between the contractor and the owner. So then had a conversation around how do we try to assist each other in managing those risks. So one unique thing that engineers and owners have is we've been on the job for, say, 5 years before it's gone to construction, have developed relationships with key stakeholders, with our key regulators, with permitters. And the discussion there was to say, well, okay, how can we help you manage your risks with the relationships that we have? And so contractor, how do you help us manage our risks, which are related to schedule delays, cost certainty? And that turned into a really collaborative discussion. They continue to have joint risk workshops every so often to go through the risk profile, see if it's changed. And I think that that's a really great example where collaboration has worked. I have talked to a number of owners who have the opposite opinion and who have experienced exactly the issues you've described, where there's a problem with liability down the line when you get to a change order and there was perhaps a perceived sort of too much openness at the beginning. So really, I think it's a function of one, so what are the experiences of the owner, and then two, what kind of an environment do you want to create as it relates to risk? Because even if you don't share as much about risk from the outset, with good partnering, you would still have a really good approach to addressing those risks if they do occur during construction.
Amazing, and that kind of leads into this next question. So this specifically focuses on a fixed price project, and the question is, should the risk register from the design stage be shared with the contractor?
I think that's probably a function of project to project. I mean, I think when we write a risk register, we are always trying to think about it in terms of this is a living document that is going to make its way through to the end of construction. Now, so whether that document is is going to be shared with the contractor versus if it's part of the contract documents or if it's just a part of the informational documents that are passed over, I think that's really a function of sort of project to project and owner to owner. I think at the very least there should be a good discussion around risk with the contractor, whether or not the actual risk register is shared, but just talking about what risks you had, what you perceive to be their consequence versus their probability is a really helpful way to understand how everybody can be a part of developing a solution to those risks.
Phenomenal. Okay, so the next couple questions are related to contingency. And so the first one is, would you release contingency by phase of the project or on a quarterly basis, or would you go milestone based?
Yeah, so that's really a function, I guess, of the owner and the way that they identify their funds. There are owners that need to ask for money quite early on, and then they go back at the point of the construction contract to confirm what that number is. And so I think there's a bit of a difference there in terms of how they might manage contingency. The concept of contingency is also an interesting one, just because it might not be a real thing in some cases. So if you have a project where they just grab money as they need it, contingency is really there to see if you're overspending on anything. It's not really an entity where you have to go back and ask for anything. If you're a public company that gets all their money from a board of directors and from requests, you might be more likely then to have a contingency milestone that is procurement, where you say, okay, we got our cost estimates in, we then have our own internal assessment of contingency, so this is the amount of money we're going to ask for, with the intention of not having to go back to that board. So you might have a higher confidence that you use to select your contingency so that you don't have to go back. I'd say during construction, no matter sort of how you're going to report or how you get your money, really useful to identify a couple of key hold points or milestones during construction. And I think, so as we've all seen, the vast majority of the risks exists in the underground component of jobs, so whether it's the shafts or the tunnels. So I mean, having a couple of key milestones around, the completion of shaft, the completion of the tunnel, the demobilization of your tunneling contractor, that really helps you understand, like, when is the majority of the risk behind you, and then when do you move into a smaller amount of contingency being needed to complete some of those surface works.
Okay, and then in your experience, does the presence of a contingency almost always lead the project/contractor to exhaust it somehow before the end, or are there some incentives built into the tender package to save on the contingencies?
Yeah, that's a really great question, and I wish I had a good answer for you other than it really depends on project to project. I mean, what you might see are things like, we're going to do liquidated damages because we want to make sure we have a set completion date that we have selected sort of based on our sort of risk assessment of how long we think this would take. And therefore, you're really trying to communicate, when do we need you to be done? Because at that point, the owner might incur costs because it's either not in place when they said it would be, or they have a sort of in-service date that they've agreed to with sort of some of the permitters or sort of regulators, and so they want to share that cost impact with the contractor. The other way to look at that is you could also have incentives to complete by a certain date, where you're really trying to encourage a contractor to show innovation, to complete the job either before the scheduled date or sort of below the costs, so that you can sort of pay out a bit of that to say, so thank you for getting us done earlier. And so as a result, we've not had to incur additional costs, which would come out of our contingency. So there are a couple of ways to skin that cat. I think everybody sort of knows there is contingency. I mean, contractors will carry their own contingency based on the risks that they have to manage. The owners will carry their own contingency based on the risks they have to manage. So everybody sort of knows about it. If you were to disclose the amount, that would probably change the dynamic of how risks are viewed and how they're managed. So I don't think anybody's keen to sort of share the amount of money they've allocated to risk, but certainly to share the kinds of risks they need to manage. That's a good way to promote partnering and to promote management of risk in a healthy way. That's not sort of giving away too much information that might lead to people just thinking they can spend contingency whenever they want.
Okay, so this one's interesting. So the comment reads, Brent Flyberg has statistically quantified the level of inaccuracy in cost estimates of transportation infrastructure projects, including fixed link projects such as tunnels, and arrived at the conclusion that consistent cost underestimation is due to conscious lying on behalf of bidders and not technical or project management error. And so it's more so, what is your opinion about this assertion?
So that relates to a really interesting thing called optimism bias, which is the idea that things are going to be better because we kind of hope that they will. And the piece that Flyberg's talking about in terms of sort of conscious lying, which is an interesting sort of way to package that up, is another concept, which is that, you know what, like projects won't go ahead if they sound like they're going to cost way more money. So if you said, hey, it's going to cost $1 billion, people might say, oh, geez, we're not going to pay for that. But if you say it's going to cost $600 million, maybe it would go ahead. And then you're sort of adjusting the cost estimate as you go. Can't comment on whether politicians are being truthful or lying. I think that the idea, or the concept of optimism bias is a really important one for us to consider, just because if you've executed a project successfully before, you're going to carry some of that optimism bias forward, that, hey, this is going to get done, don't worry about it, we'll probably incur less risk than we think. The way you beat that is a structured approach to risk management. So you go through your risk analysis, you go through your risk assessment, so you have a reasonable way to look at what would be unacceptable versus acceptable, and then you apply mitigation measures that make sense for the job. And as we see, like, projects getting bigger and bigger and bigger and bigger these days, it's really important to address optimism bias, because if you're off, so say it's a $200 million job and you think it's going to cost 180 and it comes in at 200, not as big of a deal compared to if you think it's going to be 6 billion and it ends up being 8 billion. That's a considerable impact to ratepayers, to taxpayers, and therefore that can have a reputational risk where you would never do another tunnel again because it was so over budget and so behind schedule.
Right. Okay. And then I think the last couple questions are just, there's a lot of interest in this subject. And so do you have any recommendations on further reading materials or where to go in? Like, what sources would you seek out if you wanted to learn more about risk and risk management?
That's a great question. And so maybe what I'll do is in the slides before we post them, I will include a slide of a couple of textbooks and a couple of papers that are really interesting to read. The Project Management Institute, PMI, so they have a structured approach to risk. So I mean that's a good place to start to get some of the background on sort of risk management, what the terms are, the way that they're used. There are some great books on underground risk management. The UCA has a book that was written by Joe O'Carroll, which is a really great summary of the way we try to address and manage risk on specifically underground construction projects. And I'll include that in the sort of list of potential reading as we post the slides there. So I'll take that action and include that in the PDF once I send it over.
Perfect. Okay, so that leads us to the top of the hour, and once again, I'd like to say thank you, Connor, for this phenomenal talk. Super interesting as always. Learned a whole bunch. For everybody who's still on the call, this was recorded and will show up on the TAC website shortly. We're working on posting all of the videos and the slides from these different webinars. And so stay tuned for an announcement when they are up. That will most likely come via the newsletter and we'll post on social media. We're still finalizing our details for our next talk, so stay tuned to your emails and to social media for more details on the next Intro to Tunneling webinar series. So,
perfect. Thank you very much, everybody. And so if you have any other questions, feel free to send me an email, and would be happy to chat with you more about risk management as well.